And this is our demo of our project proposal. That is a smart dustbin with IoT functionality. My name is Suhas, and my group members are Lloyd and Dion, and we will be walking you guys through our application. So, just a brief on our project topic. It's the smart dustbin with IoT notifications, as I mentioned. Essentially, it will use object detection sensors and level sensing to know when a person is nearby and open the lid and close the lid, so that there's no user. The user does not have to touch the dustbins. Um, it also has senses the level of the trash inside, and once it reaches a certain limit, it notifies whoever is using the dustbin. So we built the demo on Tinkercad, the online tool. Um, as you can see on the screen, we have the Arduino, the servo motors, the two sensors. Yeah, so we have written the code as well, so that we can run the simulation, which my teammates will walk us through. Moving on, Lloyd will talk more about our demo.
Let's take a look at the system architecture of our smart dustbin. In the middle, we see an Arduino, which is used as the controller for our entire project. Now, this Arduino is connected to several modules. First, we notice the red LED and green LED present at the top. These are connected via analog pins of the Arduino, and they denote whether the dustbin can or cannot be opened. We also have two ultrasonic sensors. One is placed inside the lid of the dustbin to detect the level of the waste. Now this level decides whether or not the dustbin can be opened. The other ultrasonic sensor detects the presence of a person in order to open the dustbin. So if the person is close enough distance wise, the dustbin will open as long as the level of the dustbin is not full. The lid is opened by the servo motor, which is connected simply with 3 pins to the voltage supply, ground, and the PWM pin. Now this is used to lift the lid up. The ultrasonic sensors have trigger pins and echo pins that need to be connected to the Arduino. Further, there is a thin film display, transistor display, which is connected with 9 pins. Now these 9 pins are denoted as follows. And the key ones are the clock, the master output slave input, the master input slave output, the chip select, the voltage supply, and the ground. As long as these are connected, the thin film display will work. We also have a LoRa module, which is used to communicate with another LoRa module, which is connected to a PC. Now the data is transmitted from the Arduino to the LoRa module and fro via these two pins, RX and TX, which are connected to pin number 4 and 5 of the LoRa module. So we took this system architecture and we tried to implement it on another software called Tinkercad, a simulation software. Now this simulation software looks like this, and these are the connections we have made. Here we see an object detection sensor, which is whether the person is close enough to the dustbin or not to open it. And this ultrasonic sensor detects the level of waste. This is the servo motor present as denoted, and it needs its own power supply as well as an oscilloscope to notice whether there is a pulse that is sent towards it. This is the Arduino is controlling all of the processes. As you can see, there are two modules missing from this simulation software. The TFT display and the LoRa module, unfortunately, are not on software and thus cannot be simulated as we desire. Although this is the case, we will make sure to write the code that works for the modules and so that a project can be realized fully. Now we will move on to the simulation and the discussion of code.
Hi, I am Dion. Now that Lloyd explained the hardware setup and what each component of the circuit does, I will run the simulation to demonstrate the working and later explain the code. For the purpose of demonstration, since Tinkercad does not have a TFT display as we would ideally like, we shall use the serial monitor down here for all display purposes as well as control later on. So as you can see, there are two ultrasonic sensors, and the states of both these sensors decides whether the lid of the dustbin should be open or closed or remain closed if it's already full. We have limited the range of the object detection sensor up here to be 1 meter and the capacity sensor to 75 centimeters, which is assumed to be the diameter of the bin. So in the first case, the dustbin is not at full capacity, which is indicated by the marker out here, which is beyond the region of 75 centimeters. Now when an object is moved within 1 meter of the bin, it triggers the servo motor and turns 90 degrees to lift the lid of the dustbin, as you can see over here. An indication is also given on the serial monitor, which should ideally be a TFT display, and the bin stays open as long as the person is detected, and it closes once he moves at a distance of greater than 1 meter. So once he's away from the bin, the servo motor is triggered and it closes, which again is displayed on the serial monitor. It says dustbin closed. Secondly, when the capacity sensor down here detects an object in its range, which would include the dustbin is at its full capacity. So firstly, you have it open. Now when you have the dustbin filling up and it detects an object within its range, this indicates that the dustbin is full and the servo is closed. Now you see, irrespective of whether a person is detected close to the dustbin or not, the dustbin is closed because it is at full capacity. So whether he moves away or is near, the dustbin remains closed so that it does not overflow. Now coming to the code, our code essentially consists of 5 functions, which include the setup and the loop function. So we have 2 functions controlling the 2 ultrasonic sensors which activate the trigger and detect the echo in order to calculate the distance. So the main difference between these 2 functions is the range of the sensors essentially. So the object detection sensor being at 1 meter distance and the capacity sensor limited to 75 centimeters. We then have the display function To control the serial monitor, which displays appropriate messages on the screen depending on the states of the two ultrasonic sensors and the status of the bin lid. We then have the setup function, which declares and states the physical connection of the variables to the appropriate pins. And finally, we have the loop, which gets the whole program up and running continuously by making appropriate decisions of the lid actions. And with that, we conclude our midterm demonstration of a smart dustbin.